My talk is named Knowing Your State Machines. My name is Tobias Nyholm, and here's my Twitter handle if you want to harass me for the next 45 minutes. I can't really defend myself, so feel free. I'm going to talk about state machines because I believe that web developers only cares about printing out HTML as quick as possible. They don't care about fancy algorithm or data structures. So this is something I want to introduce to you to make your code a little bit more elegant. And I didn't really bring a state machine with me today. I don't got one in my pocket. I don't have one at home. A state machine is more of a, it's not a real thing. It's just something that holds states or defines rules between states. And states could be anything. I mean, consider a traffic light or the small indicators on your washing machine or a pull request. So it's basically a way of thinking and it's a way of relating to your problems. And it's a lot of words on this slide. I mean, this is a slide you show for the manager. If you adapt this way of thinking, you will get all those things for free. Short about me, I am a web developer at happier.com. We're trying to match people and companies on soft skills. I do some Symfony, I do PHP meetups in Stockholm, and I do plenty of open source. I started my open source career in my real open source career in 2016 or 15. PSR6 just came out, so me and my friends started building adapters between PSR6 and Doctrine, and then we thought, hey, let's implement this instead of doing just adapters. So we started with PHP Cache. At the same time, I started with HTTP Plug, which is an kind of an abstraction over HTTP clients. And when you do HTTP clients, you obviously do a lot of API clients, a lot of mail clients, and a lot of, a lot of HTTP. I mean, I'm a maintainer of both Guzzle and Buzz at the moment, and I'm writing some PSRs, and I'm doing testing, geocoding. I do plenty of things online. My absolute favorite library, though, is the NSA one. NSA totally violates class privacy. So you can access private properties or private methods with ease if you're using NSA. So let's get started. I think we should do some theory, and then we should do some examples and some more code examples, and ending up with some examples. Does that work for you? Excellent, because I have slides for this. So, graph theory. The first thing you need to know about graph theory is that these are not graphs. These are charts, these are diagrams, or these are whatever. These are not graphs. A graph has nodes, and a bit more complicated graph has more nodes, and they're connected with edges. And edges can be either undirected or directed, or they can have a weight. This is the basic. This is a basic graph theory. Show of hands, how many of you know this from before? Is this easy stuff, or is this the first time you heard it? Easy stuff. About half. Excellent. Good. Then I know your kind of level here. Consider this graph. This graph could represent anything. It could be cities and the roads between them. It could be computers in a network. It could be people and which other people they know. And if you slap on some numbers here, it could be the distance between the cities, or it could be how much data you can transfer from one computer to another, or it could be how much one person likes another person. So say that we want to find out the maximum, say there's our computer network. Say we want to find out the maximum amount of data we can transmit from A to B. How would we do that? The solution, this is called the maximum flow problem, and there is a already defined solution to this. Or say say this is cities, and we want to find out the shortest distance. I mean, you can use Dijkstra's algorithm or breadth first search to find what's the shortest distance. Or say that these are cities again, and you want to find out the cheapest way to visiting all the cities. That is called the traveling salesman problem, and there's already an algorithm solving that as well. Or say that you're a company that should lay out some electricity wires between the cities. What is the shortest amount of wire you have to buy to cover all the cities? And that's the minimum spanning tree problem, and there's a solution to that already. My point is that if you can express your problem as a graph problem, there's probably already a solution to it. So you don't have to solve the problems anymore. You can only solve the problem of converting it to a graph problem. So this is the graph theory. The graph theory is large. It contains a lot. And the cool thing you can do with graphs is you can add some constraints to it. Let's consider this graph. If we have a constraint, if we add a constraint to this and say, we forbid all loops. You can't do loops anymore. And now we have a tree. And the theory of tree is a little bit smaller than the big graph one. If you continue adding constraints on a graph, you will get a workflow. And a workflow, I'll show you, it also has nodes and edges, but we have decided that the edges between them should always be directed, and we call them arcs. And we also decided that there are two kinds of nodes. There are places and transitions. And we draw transitions like this. So this is our restrictions we're adding on this graph, and now we have a workflow. We also have, I'm not sure if I told you, but a place could not be connected to another place. There has to be a transition in between, just like this. So like an example of a workflow is this. So this tells you how, if you want to move from A to C, you're going to execute the transition T0. If you want to move, if you execute the transition T1, if you are in B, then you get to C and B, C and D. If you continue adding constraints here, if you have added constraints that a transition can only have one input and one output, and the name has to be unique, now we finally got a state machine. And what I want to tell you here is a state machine is nothing complicated. It's just a simple graph with some restrictions on it. And since I'm drawing this by hand, and I think it's easy to read, I'm using this notation instead. There is a transition by drawing it as an edge. So we started out with a big graph. Then we saw what trees were, and then we have workflows, and then now we have state machines. So a state machine is nothing but a graph. So let's dig deep here. Let's go into what is a state machine really. This is a traffic light. I've decided that a traffic light has 3 states. It has green, has yellow, and has red. And I decided how to move between these states. So as you can see, I can move from green to yellow to red, and I can move back from red to yellow to green. But there's no arrow from green to red. I've decided that there's no traffic light that can directly go from green to red. It has to go via the yellow node. I told you I work at Happier, and we're matching people and companies, and we obviously have a lot of adverts, job adverts. So we've decided in a business meeting that we should have this state machine for job adverts. So when you create a job advert, it can be in draft. Then you could send it to review. From review, you can either trash it or publish it. If you decide to trash it, you can untrash it, go back to draft. If you publish it, it becomes published. And after a while, you can archive it. This is easy for you, right? This is not rocket science. So what is this a state machine for? I hear pull request and PR, and yes, this is the state machine for pull request. And I don't know how much open source you're doing, but you submit a PR, and then Travis is running for a while, and you obviously find some issues, so you can update it yourself, or you can wait for review, and the review says you should update it, or they could say that review could say that some changes is needed, so you go back to coding and update it, and the review, the pull request could either be accepted or rejected. And if it's rejected, it's hopefully going to be reopened. How about this one then? Yeah, doors, valve, sure. I usually say, no, not doors, it's elevator doors, because this is what anyhow. Some people have trouble understanding this. I think that, if you've seen a set of elevator doors, they're either open or closed. And they don't go directly from open to closed, right? They have to be closing for at least a second. And if you're doing that second, you click on the open button, the door gets open again. So this is, I mean, I know I spend too much time on this, but people really want to understand this. So say that the doors are closed. If I click the open button, the doors are opening until the sensor notices that they're opened, and we enter the state of opened. And when you're opening, if someone clicked the button, then it changes to closing. You could also add a state machine on multi-steps forms. When you apply for a job at Happier, it's a 5 or 6 step process. So basically, this is the process. So I keep track on where's the last completed step in this process. I could also be even friendlier to allow the user to have a state machine that keeps track on if you allow to go back or forth in my form. So I can have one state machine for the last completed step, and also one state machine for last completed or the last visited page. So if the user takes a break and comes back and can direct them to the correct page, so the correct step in the form. So I guess you kind of know how state machine works by now. So let's see some implementation. And there are 2 major implementations. There are the more state machine and the mealy state machine. The more state machine implements the state pattern. And one is simpler, one is more complicated. The more state machine only cares about the current state. It takes the decision, decision only depends on the current state. The mealy state machine takes decisions on the current state and some input. So I'll talk about them both. Let's consider the state pattern, the more state machine first. To implement this, you have to have one large state machine object, and you have one object for each state. Say that I want to have a user sign up, and I want to encourage them or remind them to fill in their profile. I mean, I send 2 emails saying, hey, you should add your name here. Or if they add a name, I say, hey, you should upload your image or upload your resume. Since I'm only caring about the current state, I implement this that every state object has only one method, and that's the send. So the real goal here is that I have a cron job or a worker somehow that fetches all the state machines from the database and then just starts. And the worker doesn't really care which mail should be sent. That logic is implemented in the state themselves. So bear with me here. You will see the slide in a minute again. So I fetch all the state machines from the database, and then I just loop through them and start them all. And I start them and they will handle themselves pretty much. And my big state machine implementation looks something like this. The interesting part's in the middle. I basically says that when I get started, I just take the current state and execute the send function. The state machine here doesn't really care about which state it is, doesn't really care about which email it was sent. And also, the states themselves are responsible for moving the state machine to the next state. So here, I'm still very stupid. I'm also, when the state machine finally ended, I check, I'm in the final state. If I'm in the final state, I go and remove myself. So are you fine with this, by the way? You kind of get it. We'll get back to this when you hopefully fully get it. A normal state or any state in this is basically just this. It has a send method, and it prepares an email and send it. And afterwards, I move the state machine to a different state. I obviously have to do some preconditioning. So if you already have your name added, don't send an email about adding your name. So in this case, if the user already has a name, then I move to the remind me about the image state. And I also have to do some trickery to not send out every email at once. So I gotta make sure that I have some spacing between this. So if I have been in this state for a week, then I'll send then I send another email. Make sense? So this is pretty much what I do for every state. I'm like, for the image thing, I'm checking if you have an image, then go to the next state and also make sure that it has some time has elapsed. So I created all my states, something like this. And now it kind of makes sense to have this worker that just starts state machines and you understand that the states handle themselves. You kind of get the state pattern in the more state machine. Kind of. I mean, you have one class for each state and the one method for each state that sends the emails. And each state defines the next possible states. And you will obviously have some trouble saving this state machine in the database because you have to save the state machine and also the current state, and they have to hold some values. So there's some trickery with here. And using this email example, this is the state pattern is great for like sending emails, just doing something like this. However, I haven't found another example using the more pattern, or the state pattern with a more state machine. It's not because it's bad, it's just because the melee state machine is so much better for everything else. It's even better for this specific use case. So let's consider the traffic light again. Let's try to implement this. So in the melee pattern, we have one class that does everything. So if we want to implement a state machine for this, we could do something like this. We define all our states, and then we have a private property that holds the current state. And it may be good with a can function. So you can ask state machine, can we do this? And I'm doing some, I'm not sure if this is the best implementation, but I have a switch statement here that's checked if I'm in the current state, if I'm in state green, then I only can do transition to yellow. And I also think it's a good idea to have a function that applies a new state. So I can say to the state machine, hey, let's apply to yellow. So my apply function could be implemented like this. I just check if I can do it. If I can't, I just throw an exception. And then I actually apply I update my private property. So this is great, or this is okay. There's an issue here. If I go back a slide, I see that my state machine actually holds state, which means that I have to save the state machine in a database to actually remember this actual state. And I want to get around this somehow. So if I go forward, so if I instead inject a traffic light object into this can function, the state machine doesn't hold state anymore. I don't have to save my state machine in the database. So my state machine is stateless, or this state machine should only hold the rules how to move between the states. It shouldn't hold the state itself. So I just inject my traffic light and I say get the current state from the traffic light object and then do the very same thing. And similar with the apply function. So I feel pretty good about myself right now, don't I? And I might be interested in doing something like this. I mean, I want to, no matter what state the traffic light is in right now, I want to allow more traffic. So I'm going to push it towards green. So I might be tempted to implement something like this, which works. I could also have like stop traffic. So if I know no matter which state I'm in currently in, if I call stop traffic twice, it's going to be red. So this is my nice little helper functions. So this works. This state machine class is okay. It's a bit messy with the transitions all over the place. So let's try make this somewhat more reusable. Let's try to improve somehow. And the first thing to make it more reusable is you shouldn't use this. I mean, if you want to have state machine for pull requests in the same class, you couldn't have allow more traffic functions. So let's remove this. And let's clean up the state machine a little bit. By instead of having states all over the place, let's have them in a private property instead. So as you can see, my apply and my can function gets a bit more simpler. It just checks if the current state and transition is set in this big array. It looks like a lot, but when you realize that it isn't, it's quite simple. And if you want to make this a little more reusable, let's inject the states instead. Instead of adding them in the class, let's inject them. So I just add a constructor, and this is the same code I just moved up. I just add a constructor that I can inject my states. And what if, this state machine is hardwired to the traffic light object, right? So let's create an interface or something like this. So I create a state-aware interface, which has two functions, just get current state and set state. So this state machine is more reusable, right? I can use it for anything and doesn't hold state, so I don't have to store it. And you did understand the end result fully, right? It's not complicated. And, oh, sure, question.
Yeah, just one remark. You have two instances of traffic light variable there that you might want to change for your next presentation. Just a little feedback.
Yeah, that's right. That's right. Except for this small bug, this state machine. This is pretty simple. I want to stress that this is very simple. You all understand this. And I will also say this is the exact same thing as a Symfony Workflow component. We basically built the component now. This is one of my favorite components because it's so small. It doesn't do a lot of things, and it's very straightforward. I think the complete component is like 15 classes. It's nothing more complicated than that. There is more features, though. There are more features, but it's not more complicated. Some functions of the workflow component and that state machine is we have the can we do transition. We also have the apply transition. And in additional, we have what is our current state and what transitions can we do now. This is the 4 only public functions on the state machine, on the workflow component. And let's go back to my job advert and see this in real life. So I mark the current state. We're currently in draft. And if I get my state machine, and I get the state machine for this specific advert, I can get a marking store. That's a bit complicated for some reasons. I get a marking store and ask, what are my current states? And if I dump this, I see I'm in draft. It's weird that it's an array, but I'll tell you about that later. For now, it's just weird. And I can ask my state machine, can I do publish? And I can ask my state machine, can I go to review? And if I apply to review, I change my state. And from here, I can apply trash, and I can apply untrash, and I can go back to review. And if I ask in review, like, hey, which transitions can I do? I'll get an array and I can echo out the name of transitions. This is also very same thing in Twig. I can do the very same thing in Twig. Imagine my edit page for my job advert. Looks like the WordPress edit page. I mean, I have a big text box and I have a sidebar with some links that I can do things. This could be my sidebar. This could be my sidebar implementation. Because I'm just checking, like, if I can do to review, show the review button. Or if I can do publish, show the publish button. And so for the same sidebar for different object looks different. And I could also be if I was doing some trickery with the routing names and transition names, I could reuse them somehow and also a translation key. So I could print a sidebar like this. this is, I mean, this looks messy and it's easy to break, but I could do something like this. Back to this. You've seen it a few times now, and you've probably seen an issue with this. Or maybe you haven't seen an issue with this. But you could see this and think, how come we can't trash something that's in draft? I mean, and that's a valid question, right? So we should be able to trash something in draft. So I just add this arrow here. I change my configuration a little bit. I don't change my models. I don't change my controllers. I don't change any logic. And I don't change any views. And still, my sidebar works. You have the trash button now. Oh, sorry, you maybe didn't hear me. You only changed your configuration. You didn't change your models. You didn't change your logic. You didn't change the view layer at all. And it works. It works automatically. So thank you.
I have a concern with that. The business logic should be owned by the model. So you should be changing the model actually.
Not necessarily. Not how I move, how my model moves between different states. That's
logic, right? That's business logic. If I want to move my entity review, that's logic, right?
that's something that belongs to configuration in this case. And speaking about configuration, this is how I configure. This is how I configured my state machine. And the configuration is quite simple. I mean, you just say that this is a workflow named job advert, and this is a type state machine, and it applies to this entity, and here's all my places, and here are how I can move between the places. So this is where, if I have my business logic change, this is where I just add the. This is just what I add where I change the rules. And if you've been very, very careful when you're listening to this, you might see that I have an issue in this row. I told you a state machine, the transition of state machine only have one input and one output. And this is clearly looks like I have two inputs here. Actually, under the hood, we're creating two transitions for this that named trash. So this is fine, but it looks a bit weird. So about these small weird things I've been talking about, I mean, why do you return an array when I ask for places? It's because this is called the workflow component, and the workflow and the state machine, they are similar, but a bit different. This is an example that I borrowed. It's about the blog post. And yeah, we'll just play this. The blog post starts in draft, and then I then I do the transition request review. So I want to have a review from both the spell checker and the journalist. And as you can see now, I'm in two places at the same time. And this is fine since it's a workflow and not a state machine. So I can be in two places at once, and the spell check is kind of automatic, so it goes pretty quickly. And now if I try to publish this, I can't because I don't have the, my current places is not the correct input for the publish transition. So I can't publish this until the journalist has approved it. Then I can publish it. So the major difference between a workflow and a state machine is workflows can be in two places at the same time. Workflows rarely have loops. State machines like kind of encourage loops. I mean, you see the traffic lights, only loops. And I usually been asked, when should I use a state machine and when should I use a workflow? And there's no real rule of thumb. I mean, use a workflow is if you have a clear workflow, like the multi-step form thing. Like that's a clear workflow. And I tend to use state machines all over the place because I think there's easier to relate to. The important thing is that you know what you're dealing with. I mean, you can't really relate to a workflow and think of it as a state machine. I mean, you should only know what you're dealing with and you know how to use them. So it's not really important which one you use. I'm not sure how well you are with the Symfony ecosystem, but a main thing Symfony ecosystem is that they use the event dispatcher to connect all the components. And the workflow component is not an exception. The workflow component actually throws out like 21 events when something happens. So if you do one transition, like 21 events is fired. And there are events of 3 different levels. I mean, the first one is workflow leave. For any workflow, when you leave any node, this event is fired. And then you have workflow, just the job advert workflow, and when you leave, this event is fired. And also when you leave a specific node. So this is where you hook into and where you start listening to. Same thing with when you've done a transition. And same thing when you enter a node, and when you have entered a node, and when you are complete entering a node, and when you announce yourself that you're done with everything in a new node. These last 4 seems very, very similar, and they were added in later PRs, not the initial PR for the component. And there are actually good reasons for having those. I mean, I've reviewed the PRs, and there are good reasons. It has something to do with doctrine, flushing, or something. But basically, you just need the leave and enter or announce. So this is the way you can hook into, which kind of change the logic of, this way you hook into the workflow component. If you want to change the logic, however, you could use a guard event. This has nothing to do with the security component, as you may think. It's basically if you want to have like a third-party or a third-party dependency on if you're allowed to do a transition or not. So say the traffic light again, or the blog post. If you want to do can publish, that's only validating on the rule of your state machine. But if you want to have some external things like the database is online, or it's daytime, or the manager in the office, then it's a good thing to add a guard event. And as you can see, this guard event, I mean, you recognize the subscriber interface? Okay, so it's, I mean, what I'm basically doing is I say, for the workflow job advert, I want to guard the publish transition. So call the guard publish function. And here I'm just checking, is this user granted the role publisher? If it isn't granted, I block this transition. I say you can't do this transition. So this is how I add more logic to my transitions. I can also use the event for log things. So I'm interested in when I leave any node I leave in my job advert, I want to log this. I'm going to write a log message saying advert with this ID perform transition from A to B. Simple. Good. I found I'm using this a lot in security voters as well. And you know security voters, where you can check for permissions and stuff. So here I am with my job advert again. And if I want to check if you're allowed to view a job advert, I just check if the job advert is in the state publish. Then of course everybody's allowed to view it. If it's in the state draft, nobody's allowed to view it, unless someone else's logic. So this is how I I rely on the workflow states. I can also very much rely on the events, because this is my business logic. This is how I know that every time I publish an advert, this event will be fired, right? So I can sort of I can hook into this with my business logic. So whenever a job advert entered published, I email all my users, or the users that are interested in this. Obviously, I don't email all my users, but you get a point. When I implement a new feature or implement a new entity, I write on the whiteboard saying like how does the state machine look? How can I move between different states? And when the team is happy with the state machine we got, we start implementing this in configuration. And then this command is excellent. You just dump your state machine to see, does this image look like your whiteboard? And I have to be honest, more times than not, I make mistakes in my configuration. So I found this super, super helpful to have this command dumping out things. And you use GraphWiz. That's a tool that you basically have a text file. This command dumps the text file, and you give it to GraphWiz, which generates this image. And there's some other bridges to other rendering software or whatever. You know what I mean. So you don't have to use GraphWiz if you don't like it. So I hope I kind of have convinced you that state machines are great, but how to apply them. And this is actually, This is actually a thing I struggle with at the moment. I mean, I knew about. I mean, I've been to the university. I know about state machines, but still, I've been developing for years without using them. So, where I look to find implementation of state machine or places where I can implement state machines is when I have something like this. I wrote an old CRM system, like sales are doing, setting out. Sales are doing sales. And so I wrote a system for them to keep track of the sales. And in that I have a quotation. And quotation can either be sent or in negotiation or won or lost. So I wrote a class like this. And this is a clue for me. Whenever I see this, I should think state machines instead. Because I don't have any rules. I can move how I like between the states. So if you have something like this in your code, you should consider using a state machine. Or when you have something like this in your code or in your database, I just have like booleans if it's active or ended or closed or whatever. This is also a good place where I could add state machines. And as we also said, the email reminders and multi-step forms. This is an excellent place for using state machines. And I'm asked, I mean, is it worth it adding state machines if you only have 3 states? And this is the job advert, by the way, from way past 4 years ago. I mean, sure, you could, for some scenarios, just 3 states could be too little. For the job advert, which is kind of the main thing in my application, obviously I need a state machine for this. So it's, I mean, I rather use the not, but don't over-engineer this. So I hope I've introduced you a new way of thinking, a new way to relate to your code and to your problem. And I hope you will at least try implementing some state machines. Thank you very much for your attention.